So hello everyone, in this audio class we will discuss the 20 most important questions from the chapter map projection. These questions will be very much important for your upcoming KVS NVS PGT Geography Interview. So let's get started with the question number 1. What do you understand by a map projection? So map projection is the method of transferring the graticule of latitudes and longitudes from the spherical earth onto a plane surface. The earth is approximately spherical, but maps are drawn on flat paper. Therefore we need a scientific method to represent the curved surface on a plane. For example, when we draw a world map in an atlas, we actually transfer the curved network of meridians and parallels on a flat sheet through a projection. Next question, why do we need map projections? So a globe is the best model of the earth because it shows shapes, areas, distances and directions more accurately. However, a globe has several limitations. It is bulky and expensive. It cannot be carried anywhere. Minor details cannot be shown clearly. Comparative studies are difficult. Therefore, map projections are necessary. For example, if we want to compare the population distribution of India and Brazil, it is easier to do it on a map than on a globe. Next question. Can a map projection represent the earth perfectly? No. The earth is a non-developable curved surface. When we transfer it onto a plane surface, some distortion is inevitable. A projection can preserve one or two properties, but it cannot preserve all properties simultaneously. The distortion generally occur in area, shape, distance, direction. For example, Greenland appears almost equal to Africa on Mercator's projection, although Africa is nearly 14 times larger. Next question, what is meant by graticule? So the network formed by parallels of latitude and meridians of longitude is called graticule. It acts as the geographical reference system for locating places on the earth. For example, the position of Kolkata can be identified only because the earth has a network of latitudes and longitudes. Next question, what are the four global properties of a map projection? So the four properties are area, shape, distance, direction. No projection can preserve all four properties simultaneously. Therefore, cartographers choose projections according to their objectives. For example, for navigation, direction is more important than area, so Mercator's projection is preferred. Next question, what is an equal area projection? So an equal area projection preserves the correct proportion of areas. However, shape and angles may become distorted. For example, the Lambert's cylindrical equal area projection, the relative sizes of continents remain correct. Africa appears much larger than Greenland because its actual size is much greater. Next question, what is the orthomorphic or conformal projection? So an orthomorphic projection preserves local shapes and angles. However, area becomes distorted. For example, Mercator's projection preserves the shape of small regions and is therefore highly useful for marine navigation. Next question, why is Mercator's projection called an orthomorphic projection? So in Mercator's projection, meridians and parallels intersect each other at right angles everywhere. As a result, local shapes and angles remain correct. However, the scale increases towards the poles and area distortion becomes very large. For example, Greenland appears enormously enlarged. Next question, why is Mercator's projection important for navigation? So its greatest advantage is that a straight line on this projection represents a line of constant bearing or Rhumb line or loxodrome line. Sailors and navigators can follow a constant compass direction. For example, ships crossing the Atlantic Ocean can follow a constant bearing easily on Mercator's map. Next question, why does distortion increase towards the poles in Mercator's projection? So the spacing between parallels increases progressively towards the poles. Consequently, scale exaggeration becomes very high in higher latitudes. For example, Antarctica appears unrealistically large on many world maps. Next question, what is meant by a developable surface? So a developable surface can be flattened without stretching, tearing or creasing. For example, cylinder, cone and plane surface. These surfaces are used to construct map projections. Next question, why is the globe called a non-developable surface? So the spherical earth cannot be flattened into a plane without distortion. Therefore some distortion always occurs in map projections. For example, if we try to flatten the peel of an orange, it tears and wrinkles. The same problem occurs while projecting the earth. Next question, how are projections classified according to the method of construction? So they are classified into perspective projection or mathematical or conventional projection. So perspective projections are obtained by projecting the graticules using a source of light, and mathematical projections are derived by mathematical calculations and formula. Next question, what are cylindrical projection? So a cylindrical projection, the globe is projected onto a cylinder touching the globe at the equator. When the cylinder is opened, a rectangular graticule is obtained. For characteristics of cylindrical projection, meridians are straight and parallels are straight and parallel. For example, Mercator's projection and Lambert's cylindrical equal area projection. Next question, why are cylindrical projections suitable for equatorial regions? So the cylinder touches the globe at the equator. Therefore, scale distortion is minimum around the equatorial region and increases towards the poles. For example, distribution of tropical crops such as rice, rubber and sugarcane can be presented effectively. Next question, what are conical projections? So in conical projection, the globe is projected onto a cone touching the globe along one or two standard parallels. What are characteristics of a conical projection? So meridians are straight lines converging towards the pole, and parallels are arcs of concentric circles. Next question, why are conical projections suitable for middle latitudes? So the cone touches the globe along a standard parallel located in the middle latitudes. Hence distortion remains minimum near those latitudes. For example, USA, Europe, Canada and China are often represented using conical projections. Next question, what is a standard parallel? So the latitude where the developable surface touches or cuts the globe is called the standard parallel. As this latitude scale is true and distortion is minimum. For example, in a conical projection with one standard parallel of 40 degree north, the scale is correct along 40 degree north. What is next question? What is azimuthal projections? So azimuthal projections are obtained by projecting the globe onto a plane surface. The plane may touch pole in polar aspect, equator or equatorial aspect, or intermediate latitude, that is oblique aspect. The chief property is the preservation of directions from the center. Next question, and this is next question, if you have to teach map projections to class 11 students, how would you explain the concept? So I would begin with the globe and explain that the earth is spherical while maps are flat. Then I would show that transferring a curved surface onto a plane inevitably produces, so I would show that transferring a curved surface onto a plane inevitably produces distortions. Next, I would introduce the four global properties: area, shape, distance and direction. Finally, I would explain that different projections are designed to preserve different properties according to specific purposes. For example, for navigation, Mercator projection; for area comparison, Lambert equal area projection; for middle latitudes, Conical projections. There are some factual questions from this chapter. What projection is most suitable for navigation? Mercator's projection. What is the straight line on Mercator's map called? Rhumb line or loxodrome. What property is preserved in Mercator's projection? Shape and direction. Next question, what property is preserved in Lambert's cylindrical equal area projection? Area. Which projection is suitable for middle latitude? Conical projection. In a simple conical projection, what shape do parallels have? So arcs of concentric circles. In a conical projection, what shape do meridians have? Straight lines converging towards the pole. Which projection is most suitable for equatorial regions? Cylindrical projection. Which surface touches the globe in cylindrical projection? Cylinder. Which surface touches the globe on conical projection? Cone. Which surface touches the globe in azimuthal projection? Plane. Name four global properties: area, shape, distance and direction. Which projection preserves directions from the center? Azimuthal projection. What is the network of latitude and longitude called? Graticule. Why is globe called the best model of the earth? Because it represents shape, area, distance and direction more accurately. So there is one golden closing statement from this chapter: no map projection is perfect because the earth is a non-developable curved surface. Therefore, cartographers select a projection according to the purpose of mapping, whether the priority is area, shape, distance or direction. So thanks for listening. Keep listening for further audio classes. Thank you.